Okay, in this video, we're going to take a look at parallel lines, skew lines, and then whenever we have multiple lines cut by something called a transversal. To start things off, we're going to define parallel lines. These are coplanar lines that are never going to intersect. So they have to exist in the same plane. If they don't, we're not going to call them parallel lines. A couple symbols, this sort of double vertical arrow or line symbol, that's going to mean parallel to. And then, like we've seen before, if we want to say not parallel, we'll just put a slash to that symbol. So that's typically what you'll see in any math class. One symbol means one thing, a slash that thing means the opposite. In a diagram, some symbols that you're going to see are these little arrows to indicate which lines are parallel and which lines may not be parallel. If they don't have the arrows, we're not going to assume that they're parallel. So here, since we have those arrows on line PQ and then line RS, that's going to tell us that we can make the statement that line PQ is parallel to line RS. And if we did not have those arrows, we would put that slash to that parallel symbol. Another pair of lines that are never going to meet are called skew lines. So skew lines, they're non-coplanar lines that don't intersect. Taking a look at this diagram here, if you were to look at the line passing through FA, kind of coming forward and backward, and then the line passing through BC, those two lines exist in two totally different planes, and they will never meet each other. So the easiest way to identify some skew lines, I get a lot of students having a difficult time finding skew lines every year. Pick a line that's horizontal and then a line that's vertical, and make sure that they're not in the same plane. Like, don't pick AD, because AD and FA are in the same plane. As long as you do that, you have identified a pair of skew lines. Now we're going to take a look at what happens when we cut two different lines. This gives us something called a transversal. So the way you cut that could be multiple ways. It could be with a line, segment, ray, or even a plane. Basically, any straight object, we're pretty much only going to see lines cutting other lines. So for example, suppose I have these two lines here, and I draw this blue line that passes through those other two. That blue line would be what we call a transversal. Now, if I was to draw this red line where those two lines meet, this is not a transversal. A transversal has to cut your two lines at two separate points. If it cuts at the same point, we would not call it a transversal. Now, when we have transversals, we're going to form a bunch of angles. We've got 4 angles here and 4 angles here. And what we're going to do is see which angles might pair up. And next time, we'll see how those pairs might relate. So whenever you have a transversal, you're going to form an interior and exterior portion of the lines that you're cutting. So for example, in this picture here, I've got the transversal T that's cutting lines Q and R. Lines Q and R, well, we have some area here that's interior to both of them, or in between. And then all of the blue stuff here, that's outside of those two lines, so we would call exterior. So some interior angles we can identify are like 4 and 3. Okay, so angle 4, angle 3. Make sure we're using those angle symbols to identify those things. Angles 5 and angle 6. Okay, so those are some angles formed by a transversal cutting two different lines. Now some exterior angles, those would be like angles 1 and 2 and 8 and 7. Okay, so those are exterior angles. Consecutive interior, so the rest of these are actually going to be pairs that we look at a whole bunch this chapter. Consecutive, another way to say that is same side, and then alternate, another way to say that is opposite side. So consecutive, these are same side interior. That means that these are angles inside of the two lines cut and on the same side of our transversal. So the consecutive and the alternate, that's in reference to our transversal. So it's really good to know what is the transversal you're working with. That way you know, am I on opposite sides of the transversal? Am I on same sides of the transversal? And keep in mind, these are pairs that pull an angle from one point of intersection with an angle at the other point of intersection. So we don't really concern ourselves too much with 4 and 3 or 4 and 2. Those are all angle pairs we already know about, like vertical angles, linear pairs. We're looking at like maybe what about angles 5 and 4? So 5 and 4, those are on the same side of T. So here's T. They're on the left side of T, and they're both interior. So those are consecutive interiors. So angle 5 and 4. This is one consecutive interior angle pair. And then another pair would be angles 3 and 6. And those are the only consecutive interior angle pairs in this picture because they're interior to the two lines and they're on the same side of T. Now, some other interior angles, these are opposite sides of our transversal, would be like 4 and 6, because 4 and 6 are interior to the lines and they're on opposite sides of T. So 4 and 6, this is an alternate interior pair. We also have 3 and 5, so angle 3 and angle 5. Some exterior angle pairs, same thing. Alternate means opposite side of transversal. So those are going to be like 8 and 2 because those are outside of the two lines and they're on opposite sides of T. So angle 8 and angle 2. And then the last alternate exterior pair would be 1 and 7. Angle 1 and 7. And you might be wondering, well, where's the consecutive exterior? Sure, we could identify those like 8 and 1, 2 and 7. Those are not angle pairs we typically deal with, but you could identify them if you had to. The last pair are going to be called corresponding. So corresponding, think same position. These are pairs where one will always be interior, another will be exterior, but they're at the same position in their perspective, or I should say respective points of intersection. So looking over at this picture here, if you look at angle 6, at this point of intersection, angle 6 is in the upper right-hand corner of that intersection. Well, up here, angle 2 is in that same spot, or it's in that corresponding spot. So 2 and 6 would be corresponding. So angle 2 and angle 6. Likewise, 4 and 8, those are in the bottom left corners there. So angle 4 and 8. We also have 5 and 1. So angle 5 and angle 1. And then lastly, 7 and 3. Those are in the bottom right-hand corners. So angle 7 and angle 3. Okay, and angle 3. That's pretty much what you need to know to get a good head start on 3.1.